am Mili Trivedi from LJ Institute of Engineering and Technology, and we will study about the direct and reverse crank method. Okay, so students, you have to know about direct and reverse crank method first of all. Let us have the introduction of direct and reverse crank method. So in this method, first of all, you should know that this method is a mother of V engine, okay, as well as the radial engine. So as you see in our diagram, there is the radial engine presented here, and this radial engine is having nearly 5 cylinders. Okay, now this 5 cylinders will give us the tremendous power, and you can understand this kind of cylinders were used during Second World War. Right now we are not using radial engines, but still with some modifications we are using V engine or V inline engine, as we have already discussed in our previous sessions. Okay, so now as you see in the diagram, it is the radial engine, and V engine is also the child of direct and reverse crank method. It means direct and reverse crank method is the mother of both of this engine, radial as well as V engine. If you see in this case, it is having different engines at particular angles. Okay, so if we want to use different engines at particular angles, we have to surely use the method. Now students, this is only the hypothesis. Okay, so let us understand this. First of all, suppose there is a single cylinder engine, and assume we are putting the mirror at the line of stroke. Okay, and in our diagram, the straight horizontal line is representing the line of stroke value. Okay, so suppose if you are putting line of stroke mirror at the line of stroke, what you will see? You will see the exactly same crank at the opposite side. Okay, just like the mirror. If the crank is at theta angle, the another crank will be, the imaginary crank will be at the minus theta angle. The first crank, if it is rotate at omega angular velocity, the imaginary or the mirror crank will also rotate at omega angular velocity, but in the opposite direction. Okay, student, it is the hypothesis only. First of all, you have to remember this. Hence, I'm telling you again and again. Okay, so now imagine there is a crank and a mirror, and opposite to that mirror we will get the image of the original crank. So here we have original crank, and another one is the reflection of that. Now if we assume that we divide the mass. Okay, so if we are having m mass originally, we need to assume that in the original crank, that is m by 2 mass, and in the opposite crank there is also the m by 2 mass. Okay, now we are considering that there is the inertia force, which is Fi, which is exactly opposite to the motion. There is the resultant force, which will tend to rotate this whole system. Okay, now let us have OC is our direct crank, okay, which is the original crank. OC dash is our reverse crank. It means imaginary or mirror crank. Okay, so we'll say it as a reverse crank. Right? Now students, it is not possible if we have two different cranks rotate at two different directions and will rotate as it is. It is not possible. Okay, so this is just the hypothesis, because we need a particular plane for the rotation. Clear? So let us have OC is the original crank, OC dash is the reverse crank or imaginary crank. Okay, imaginary crank, the name imaginary crank will confuse you. Okay, because for the secondary crank we are also telling the name as the imaginary crank, so it may confuse you. So do not use that word, just to use direct and reverse crank method. Hence direct is the OC crank, that is the direct one, and OC dash is the reverse crank. Okay, now next, omega is the angular velocity and theta is the crank angle. If direct crank is theta, so reverse crank angle is minus theta. If omega is the direct crank angular rotations, so minus omega is the reverse crank angular rotation. So angular rotations are nearly similar. Rotation will not be negative anymore. Just the direction is opposite. Okay. Now let us have the calculation. Suppose there is the crank having m by 2 mass. If it is m by 2 mass, okay, so what is the force tend to act on the system? It is m by 2 omega square r. Right. Now if it is m by 2 omega square r for the direct one, exactly for the opposite one we are getting the same, which is m by 2 omega square r. Now let us assume the angle of both of them. So what is the horizontal or along the line of stroke component of direct crank? It is m by 2 omega square r cos theta. And what is for the reverse crank? So it is also m by 2 omega square r cos theta. Now let us solve this equation. For our case, for the primary forces, we are considering what is the standard primary unbalanced force. It is m omega square r cos theta. Okay. Now, if we are considering direct and reverse crank, then, so for the direct crank, it is m by 2 omega square r, the force, and the along the OP it is m by 2 omega square r cos theta, as we have already discussed. Now, for the reverse crank, which is OC dash, and along the OP, what is the reverse crank value? Yes, it is m by 2 omega square r cos theta. Now, if you see the diagram, they both are at the same direction. It means m by 2 omega square r cos theta, both the values are in the same direction. So, let us have the sum of it. So, if we are getting the sum of both the values, what we will get? We will get m by 2 omega square r cos theta as it is, which is equal to the primary unbalanced force. It means if we reduce our mass, our unbalanced force will not change at all. It means we can use it by adding some modifications. Okay, now let us have our secondary crank values. Now let us assume OD is the direct secondary crank and OD dash is reverse secondary crank. What is the final value of secondary force value? It is m omega square r cos 2 theta by n. Okay. Now, if we are having different mass, m by 2 on each side, so what we can write? M by 2 omega square r cos 2 theta by n is the secondary force for direct crank. Okay. And m by 2 omega square r cos 2 theta by n is the secondary force for reverse crank. Clear? Just angle is different, nothing else. Okay. Now, let us assume the length of direct crank. Now, as we all know, it is our reverse crank for secondary force value. And what is the radius of secondary force? As we have discussed in our inline engine, it is r by 4n. Okay. And what is the angular velocity? It is 2 omega, which is doubled. Okay. So now, let us solve our equation. The components. The first component is m by 2 omega square r cos 2 theta by n. Second component for the reverse crank, m by 2 omega square r cos 2 theta by n. Now if we will have the sum of it, what we will get? We will get m omega square r cos 2 theta by n, which is exactly same as secondary force. Okay. So if we are using secondary force or primary force, if we are using two different crank, we are getting the same value as the primary and the secondary forces. Okay. Now, this theory is very important as a point of view, because we have to study and we need to reduce the mass and want to get more and more production. Okay. Now, you have already studied about V engine, right? So in the V engine, we have studied about our numerical. So what we did in our numerical? We did and we solved our numerical like by taking the mass as nearly 1 or 2 kg approximately. Okay, so that by the help of this kind of method, we can reduce our couple values. Okay, if you see at here, we are using this single rotating mass or a mass in a same plane. If we will use rotating mass in a same plane, automatically couple will not be generated. And if couple will not be generated, then imbalanced couple forces will not be generated at all. Right? So for our system, for the V engine and for the radial engine, no couple is generated. Okay, if you remember our V engine theory, we have only solved our primary and secondary forces. Okay, we do not discuss about any couple value, right? So in this case, couple will not be generated, and if we reduce the couple effect, we will automatically balance our machine, right? So here, this is our theory of direct and reverse crank method. Thank you, student.